Welcome to Webb Homecoming. I hope you've had a good time so far. Thanks for being here to listen to their presentations. For those that I haven't met yet, my name's Emily Harris. People just call me Josie's replacement. You can call me that too, that's fine. Never fill those shoes, so that's okay. But she's here with us today too, so if you haven't got a chance to talk to her. Express to you how lost I would be without her, so she deserves all of that. So today we're going to go through the presentation, starting with freshmen through the seniors. From the class of 2028, we have Palmer Munson and Curtis Craig, who worked at Brooklyn Boat Works. After that, we'll have sophomores. We'll have Carissa Nieves and Juliet Schaefer. They were with Military Sea Lift Command during their sea term. They didn't get to go a lot of places, but I think they still got some good experiences, so they'll talk about that. And then Spencer Rankin, also from the class of 2027, he sailed with Crowley. Then from the class of 2026, we have Andre Klima. He'll talk about all of his experiences, freshman through, maybe even earlier, freshman through junior year. And then lastly, we'll end with Hendrix Levitt from the class of 2025, soon to be graduate. So I just want to say thank you to you guys. I know you have tests and presentations and quizzes and homeworks, and it never stops, and you guys know especially how that is. So for you to take the time to put this together and to present for them and for us, we really, really appreciate it. So let's give them a round of applause. And then
All right, good morning everyone. I'm Palmer Munson.
I'm Curtis Craig, and we went to Brooklyn Boatyard in Maine. I was interested in Brooklyn Boatyard because I'm interested in passenger vessels, and this was a great experience to learn about the care and detail that goes into making the spaces aboard the vessels both comfortable and functional for the passengers.
Yeah, and I have a passion for wooden boats and sailing yachts, so Brooklyn was kind of an obvious fusion of those two interests of mine.
So we're both from Minneapolis, Minnesota, so we started by driving out through Canada to Maine, which was a great experience. And on the way, we happened to stop in Marinette, Wisconsin, which is where 3 of our classmates, Kaysen, Joseph, and Caleb, also spent their winter work at Fincantieri Marinette Marine. So one of the boats behind us here is one of them, ones that they worked on a lot. Also, here's a little intro about Brooklyn Boatyard. They're a small yard of 60 people who build mainly wooden yachts, and they've got one main building, but then another portion of their business is that they store and maintain a fleet of about 150 wooden yachts that they bring in and out of the water each season.
Yeah, so here's a few pictures from the yard. You can see up here, this is their main travel lift, so everything goes in and out of the water through that travel lift. They've got another smaller one, but everything from 98-foot new builds to commercial lobster boats get put in and out of the harbor with that travel lift. They had really quite an amazing selection of industrial woodworking machinery, which I found very interesting as somebody who likes woodworking. They also had some really great people. This boat here was actually the lobster boat belonging to our boss. He had us over for dinner with a couple of Webbies, some of the guys that we worked with, and the president of the company before we left. So we met some really amazing people, and that was one of the best parts about working there, at least for me.
So this is their main building hall where all their new builds and largest repair projects are done. So that's where we worked a lot of the time, and behind it you can see the harbor, which is where they put all of the boats in the summer, and it's supposed to be very beautiful. It has a pretty crazy tidal range, so they have some issues with some of the largest boats and have to time it really carefully, which is really funny. And then also they've got a bunch of these storage sheds, which is where all of the boats are in the winter, and so they very, very carefully bring them in and out and get as much use of the space as possible. And so also some of the maintenance is done in these, where we spent some time as well.
Yeah, so this is the main shop here. You can see there's kind of 3 floors, and there's the lobster boat that we spent some time working on from the 40s named Lady Claire, and then a new build 56-foot cruising sailboat that was kind of probably 2/3 of the way through construction. Pretty large shop, space for building up to about a 100-foot yacht.
So then we, as well as working on some of the larger projects, did a bunch of odd jobs, including a lot of things involving teak decking. So we got to see kind of the whole process on that, from installing the teak decking on the new vessel, the Green 56, sanding down a different teak deck, and improving the caulking on one of the vessels that had gone a little weird. In addition to that, we did a bunch of other things like moving all of the parts for a vessel that didn't get built. So here you can see the seakeeper for a yacht that was not built. What happened was owner was planning to build 2 identical vessels, so they bought all the things and components for both, and this vessel didn't get built. So we moved all of the outfitting and the galley equipment, the lighting, everything, and the jig work that was not complete but still ready into a truck.
Yeah, so the other thing that we got to spend some time doing was composites. I wasn't really anticipating doing a lot of composite work, but it was really exciting. Kind of like I said, another thing that I find interesting is kind of the racing yacht side of things. So it was really cool to get to do some work with more carbon stuff that the shop started to do more and more of lately. This is actually the slider for a companionway for the new build that they were working on. So that was an interesting thing to learn.
We also got to see the cabin top for the Green 56 be lifted and placed on the vessel. So the companionway then went on top of this after it was installed. They did a lot of CAD work and built this separately and got it really, really precise. So they were planning for it to take a few days to land it and get everything perfect, but it was within a few millimeters and only took a few hours. And then this vessel was really unique as it was built for a couple planning to sail around the world with it, who was interested in a lot of water sports. So they had a bunch of lockers specially built for surfboards, dive compressors, and other equipment for that.
Yeah, so the 2 other boats that we spent a lot of time working on were 47-foot day sailors designed and built by the yard named Iris and Lark, so 2 Egmoggen 47s. Iris had recently been sold to a new owner on the Great Lakes, and he wanted stanchions put on her. The original owner didn't. So we spent a lot of time, this is actually Lark on the slide here. So we spent a lot of time measuring all of the stanchions and the blocking underneath the stanchions on Lark, and then transferring that to Iris, which involved a fair amount of crawling in some rather tight and also rather poorly ventilated spaces to get the blocks kind of fitted and eventually glued in.
So these are the lockers in the cockpit. We had to crawl in and out of these a lot of times around the piping that was in there to get up into where the blocks went, measure them, and then tape them off and get them all cut to size, and then put them in, glue them in, and clean it all up. And then on our way out, we then found where all of the blocks were from the deck side and measured those, and then drilled the holes through so that we could put the stanchions in and make sure they were all secured.
Yeah, so we also had some time for activities, which was fun. We went to Portland, we went to the tool store in Liberty that I wanted to go to, that a lot of the guys at the yard mentioned. We drove through Bath, which was fun, so we saw BIW, where they've been building Arleigh Burke since I think the 80s now, so that was pretty cool. And we went to the Maine Maritime Museum, which was fun, site of the old Percy and Smalls yard where the schooner Wyoming was built, largest wooden vessel ever built. So somebody who loves wooden ships, that was quite cool to see.
And then we also spent a lot of time at Acadia National Park. It was the off season and it was really snowy, but that wasn't a problem for us, so we did a lot of hiking there, which was great.
Yeah, so like I said, the other boat that we spent a lot of time working on was a lobster boat from the 40s named Lady Claire. She had been in and out of the water, various places with various people, had been sent to various yards who did things the wrong way, and so she was sent to Brooklyn to get fixed up and done up properly. So the keel needed replacing and the ends of the frames all needed replacing. So the old keel was cut out, and we were tasked with kind of making drawings of the old keel and of the old boat to make sure that when we got everything put back in, it would all fit properly as it was supposed to. So we spent a lot of time making drawings, making keel bolts, and then also planing down and kind of squaring the big timbers. They brought in a full flatbed load of 28-foot 7-inch by 14-inch pieces of white oak that had been felled, like I think a week before. So that was pretty crazy.
So here's a couple more pictures of it. You can see our supervisor on the left here taking out the keel. It was expected that the entire keel was rotten, but surprisingly, the entire middle of it was still totally fine. So it was a lot more difficult to remove the keel than they expected. So that took a significant amount of effort and ended up killing a couple sawzalls in the process. And then on the right here, you can see the new keel. So we were also given the task of getting the bolts through around the shaft log. So we had to figure out the angles and figure out a jig to make it so that we didn't hit the shaft line, because otherwise the propeller was not going to work. And so that all went through, worked great, nothing was hit, which was good.
Yeah, so this is Lady Claire when we left. She's missing her keel. So it was quite the transformation to see. I hope she's in better shape now. I'm sure she is. You can see here, this is the keel almost entirely laid up and ready to go back in. The bottom profile needed to be lofted out, and so did some of the shaping on the inside of the dead wood, but largely ready to go. So the plan is basically to roll the keel out, lift the boat up a little bit further on the jack stands, roll the keel in, and slowly lift the boat back down onto the keel. So it was unfortunate that we didn't get to finish everything, but it was really cool to see the boat go from old rotten keel, disgusting bilge to no bilge, no keel, and a half-completed keel sitting 10 feet off to the right.
So our last project was to take all of our hand drawings and turn them into a digital drawing for approval. So we took all of those lines and did them in Rhino and all of the locations of the bolts so that the Coast Guard and other agencies could certify that the boat put back together was going to be safe for passengers.
Yeah. So if you have any questions, we'd be happy to take them. Otherwise, thank you for listening to our presentation.
How much was the yacht that was the new build?
The question was, how much was the new build? I believe around $4 to $4.5 million. So to put it in perspective, the yard charges. To put it in perspective, I believe the yard charges about $70 an hour for new build labor, and they were anticipating, I believe, 1,000 hours in the main salon alone in that boat, just in fit-out work. So.
What kind of epoxy do you guys use?
The question was what kind of epoxy was used. West Systems products. So Brooklyn actually works with West Systems. They do a lot of development with them. We used a product called ProSet a lot. Brooklyn actually orders it in like 55-gallon drums of resin and hardener, and it comes out of a spool gun. And it's what they use for all the strip planking and all of the cold molding. It's actually what we use to glue on the cabin top. So we used a lot of that.
It's specially formulated for the company. They're part of the research process to make it work for what they build, basically.
Yeah, and then we used a whole bunch of different products, but all West Systems. They have a close working relationship with the guys at West Systems in Michigan.
Did either of you have prior experience in boatyards of any sort before going to this?
Not in boatyards. I've done some woodworking, and I have kind of a lot of interest in wooden boats, but I've never worked in a boatyard.
Same. I've had a little bit of experience, but haven't worked in the shipyard either.
So why did you go from hand drawing to CAD instead of CAD to hand drawing?
It was just based off of they wanted it done on like large sheets so they could see it easily, and there was no easy access computer right next to the boat, so we did it by hand to start.
And was that, back when these guys were in school, it was all hand drawing, right? So was it tough to go back to that, or is that something that you've been learning here?
We had a small bit of it in our NA1 course, so we had done a little bit, which was really helpful.
Have you ever seen a spline in ducks before?
Yes, we had actually.
Yes, although actually it was pretty. But it was pretty funny too when we were looking to first draw out the keel on paper. We spent, I think, half an hour to 45 minutes scrounging the yard to try and find splines and ducks because they had thrown them all away.
Yeah.
So.
We have some if you need them.
Awesome.
Was most of your work in the main shop or like on those, and who are some of your favorite people to work with?
Question was, where did we do most of our work and who did we enjoy working with the most? We did most of the work in the main shop. We didn't really work up the Oddfellows Hall. We spent quite a bit of time working up at the storage barns that they just got heat put in, which was
The heat was
a
very
lot nicer
helpful.
than putting it in the cold. And we worked with Noah, we worked with Sebastian or Seabass, and we worked under Eric. He was our supervisor, and we worked with Will in the design office.
Yeah.
So we had a good time. It was great. A lot of great people. Any other questions? Thank you.
Palmer and Curtis. That was really great. So great to hear about you guys. I'm Carissa Nieves.
And I'm Juliet Schaefer.
And we're from the class of 2027, and this is our presentation about our C term of the USNS Supply in Norfolk, Virginia. As we like to call it, she term, because we were the only girl-girl pairing in our class. Our agenda for today, we're going to be talking about the ship, the USNS Supply, the jobs we performed, our work environment, some special experiences we had, and end with a conclusion. The USNS Supply was stationed at Norfolk Naval Base. It's a TAOE 6, which means it's an auxiliary oiler and explosives, and it's a 6 in class. Its main purpose is to deploy with the naval fleet and perform underway replenishments, also known as UNREPs, for fuel, ammunition, and anything that the destroyers or other ships in the Navy may need. We had about 200 crew. We were the only cadets on board, which honestly was really great for us. We got to learn a lot more than we anticipated. We were only on board for 5 weeks, which was less than we hoped for, but we still made the most of it and learned a lot. Some notable ship features: the ship was 755 feet long, has 4 LM2500 gas turbines for main propulsion, and 4 diesel electric generators. Also had 22 tanks for JP5 and DFM, which are really helpful because we need to store a lot of fuel to give to other ships out at sea. Some of the jobs we performed was a lot of testing. We can get this on. Even though we didn't go underway, the crew were really helpful and turned on the gas turbines for us, turned on the diesel generators so that we can see it and be a part of that process, and it was really interesting. This is us testing the gas turbines. So they're all in these huge modules that are dampening for vibrations, and we test them and they run them every once in a while, especially now because they were on a voyage repair period, so they have to test everything and pass tests and standards. But we were testing for sparks and we did not see any, so that was good. On the right, bottom right, that was also us throttling no, that was the SSDGs. We had to run them to make sure everything was going well, even though we weren't going anywhere, but it was awesome. And then up on the top right was Juliet turning on the boiler.
We also did a lot of regular testing on the evaporator, boiler, and other systems, which is a great segue into our topic of repairs. So in this video, you can see the result of our testing of the evaporator, where a gasket immediately blew. So we got very familiar with the mops and the gasket shop. We were trusted with our second engineer. He kind of led us to the gasket shop and told us to go crazy. And we made maybe 5 different gaskets to figure out what would fit. And we were successful because by the end there was no leaking. But there were still a few other errors going on with the evaporator. So it was really interesting to see everything involved and be able to play a major role in repairing that system. We also got to work on the boiler. We had some contractors come in who replaced transducers. It turns out they wired them wrong. So we spent a very long time with our second engineer going through all of the different systems, trying to figure out why the boiler was not turning on. It turns out they swapped 2 things, so we had to find that, and while doing so, Carissa and I found an oil leak. It turns out they also forgot to tighten a valve. So we got to play a nice role in fixing that and just getting a really detailed explanation on how the boiler actually works and the different components involved while we were fixing things. I think one of the most interesting repairs we did was this last picture here. It is the fuel oil purifier. We got to completely take it apart with our, well, not completely, but mostly take it apart with our second engineer, and he sent us on a wild goose chase to find all of the repair manuals and all of the parts involved, which was taxing, but it was a really helpful process in figuring out how to do research for our winter work project and just how to get familiar with the ship and the different systems on board. It was super interesting to just see that full process and then help in such a major component on the ship.
And get oil all over ourselves in the process.
Which then brings us to our next section, grunt work. So I'm sure you're all familiar with this. In this first picture, you can see Carissa very up close and personal with one of the gas turbines on ship. We were tasked with testing the fire eyes, which are the fire detectors, and then cleaning the entire module. So we were underneath there with a hose and some soap, I've never been covered in more soot and oil. It was quite the experience. And then we also were tasked with replacing and checking the fire arrestor, which we were told would be a quick task. It took a very long time. I don't think I left the engine room that entire day except for meals. But that was still like, it was amazing to go from in class where we look at a drawing of a gas turbine to being like that close to the inner workings and actually like replacing components of it. It was amazing. We also did tank soundings, which was our first solo task. We were giving a list of different tanks to check and sent on a scavenger hunt. It felt like we did get lost a few times, but it was a really, again, a great way to see the ship and get familiar and like just feel trusted by the crew. And we were fire watch as well. We weren't allowed to do any hot work on MSC, so we got to put on welding masks and watch other people weld things, and then fit in a lot of small places, similar to what I think Curtis and Palmer had to do. But this last photo is us inside of the turbine exhaust. We got to take it off and like go in and look straight up to the sky. It was raining a little bit, but it was very cool to see. And then one more aspect of grunt work is all of the ladders we climbed with a few too many tools in our hands. It was an interesting experience.
But we survived.
We did survive.
We had a great work environment. We probably mostly worked with the engine department. A little bit of deck. We saw a lot of the deck machinery, seeing all the unrep equipment, winches. So we got to see it, and see it run. But we worked with the engine department. That's me on top of 2 of the gas turbines. So we have 2 main engine rooms, and they're mirrored on either side. So like the 2 gas turbines are here, and the other 2 are on the other side. And yeah, I'm on top of the reduction gear, which is really cool. And our crew, we were just so knowledgeable and friendly. We worked mostly with our chief engineer, Kyle Coulter, and our first engineer, Eliza Pingree, who was the first female acting chief for MSC and is now going to be a chief. So it was amazing to learn from her and meet her. And like I was saying earlier, even though we weren't out at sea, the engineering department made sure to try to teach us as much as they could and give us as much knowledge as possible. And it was so helpful for our seed term project, and honestly, our experience was fantastic. One of my favorite quotes from our engine department when we were asking about the structure of the ship is, quote, "This ship is a beast." And that kind of seemed to be the
General consensus.
the general consensus. Yeah, the supply was a really awesome ship and really helpful for the Navy. And although we didn't get to see an unwrap, we got to see the process, and it was really great.
And then while we were stuck at the pier, we were at Norfolk Navy Base, which I'm sure most of you are familiar with, very, very large base with many, many ships. We took that to our advantage, and we decided to walk around after our hours and see if we could get a ship tour. Our captain told us, yeah, just tell them you're a midshipman, and I'm sure they'll let you on board. And they did. I am still shocked. We got to go on a tour of the USS Gravely. Very detailed tour. They took us to all of the auxiliary spaces, the engine spaces. We got to go in the bridge, the CCS. It was amazing, the quality of the tour we got. Everyone was so excited to talk to us. We were allowed to go inside of, there's a big gun on the floor.
5 Hill on deck.
Yeah, we got to go inside of that, climbed up to the top, saw all of the inner workings. It was such a unique experience, and
Almost fell down.
Did they let you shoot it?
no, but they did invite us back for if we wanted to see them test like the degrees of freedom and the movement of it, except unfortunately we were on a flight back home, so it didn't quite work out, though it would have been an amazing experience. And then we were also given a tour of the General R. Ford, the aircraft carrier, which we were supposed to go on with our second engineer because the next deployment they'll be on is with the Ford. So on this tour, we didn't get to see too much because it was a snow day on the shipyard, so very little crew on the board, well, big ship, so it's a lot of people still, but we got to see some of the hot work rooms and just all the different work rooms and the equipment they used. We got to see a few of the auxiliary spaces, and then the emergency generators, which is a beast, especially thinking our ship had these high task things, but it was amazing to see. And then we also got to go on the flight deck, which is this lovely picture right here of Carissa and I. And then it was just amazing to look over the shipyard and all of the other ships. And then they had a museum dedicated to the man himself, which was amazing to see, and one of the few pictures we actually were allowed to get on the ship. And then I forgot to mention that picture up there is me holding a casing from the USS Gravely, so we were not allowed to take any other pictures, so you'll just have to take my word on everything I've said to you. But it was a really great experience to just see the variety of designs in ship and compare like 3 very different size ships with very different capabilities and tasks. It was amazing.
Some special experiences we had. We had 6 other sophomores on the same base, a few piers down, so we walked and hung out and met up with each other a few times. If you have good eyes, you can see my classmate McGregor and Alex in the middle. That's on their chain layer on Pier 1, so it was nice to see them from shore. We also got to hang out with our friends Aiden, Dom, and Julian. They were on the Patuxent, yep, and a couple of juniors were working at Combatant Craft Division at Carter Rock in Virginia Beach, so they picked us up and we were able to hang out with them as well. That's them on the right. And yeah, it was really great to take some time and hang out with some friends because we were all stuck together, so we made the most out of it. And we got to share some stories and hear what they were working on in their ship, so it was just awesome to hear about all that.
I think overall the key takeaway from this project was recognizing how much I've learned at Webb. It's really easy to forget because we're in this bubble where we're comparing ourselves to each other all the time, and it was amazing to be able to go and apply all of the knowledge I've learned in this new location and realize that Webb is teaching me all the right things and I can be competent in this new experience and have a great time. And it really gave me a lot of confidence moving on in this upcoming semester and trusting my knowledge and trusting what I've learned here. It was really great.
And furthermore, I just have to say, I had a fantastic time with Juliet, and I really enjoyed the C-term project. It's some of the upperclassmen are like, it's going to take you so many hours, blah, 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 but you get out of work and you write down all the things you've learned that day, and we learned a lot, so it was great. Yeah, any questions? Thank you. Supply.
Yes, it's a supply ship named the Supply, which is easy to remember.
What hull number was the Gravely?
66.
Look behind you.
No, that's our ship, the Supply. That would have been easy.
I'm not sure. Yeah, it's a DDG.
Yeah, it's one of the DDGs, but we can look into the hull number for you and get back to you on that one.
We were actually, we were moored right behind the coal, so if you know anything about that ship, very historic, got bombed, and so we heard a lot about that, and a couple engineers on our ship actually worked on repairing that after the attack, so it was just something interesting.
So we were forbidden to take a tour of that one.
Yeah.
All right, are there any other questions while we're up here?
Did you come away from this experience with any feeling as to the strength of the U.S. Navy in the world? As a deterrent force or as an aggressive force? Any thoughts on how you felt after your experience there?
I think our focus on the project wasn't inherently the Navy side of things, because we were working with the Supply as a supply ship, so we got to see the power of the Supply and its capabilities, but we didn't do as much discussion on the actual military aspect or those strategies involving the DDGs or something. It just wasn't the focus of while we were at ship, but it was very impressive.
We did see the amount of crew, compared to our ship. We were seeing the aircraft carrier come by, and they had hundreds of guys just pulling rope, and our crew was they can just get an electric winch. I don't know. They're yelling, heave! They choose they choose labor. I don't understand. But it was also honestly enlightening because I'm like, wow, these guys are working really hard every day. Their whole job today is to sweep snow on deck. That's reminded me that we go to a school for marine engineering, but we can wear flip-flops, so that's awesome. But yeah, that's really good. Sure.
Did you get to do any underwear replenishment?
No, unfortunately, the question was, do we get to go on any underway replenishments? Unfortunately, we were welded to the pier, or also referred to as Building 6, because we did not move. We were, the whole time we were there, we were either preparing for a voyage repair period, or we were under the voyage repair period, so we were just sitting at the base, working on repairs and checking everything that contractors have been doing and waiting on a lot of contractors. That's probably the most common task. But unfortunately, no, but we did see a lot of videos. We actually met a few people from the base who went on they were on a carrier who was on the last deployment with our ship, so we got to see some amazing videos of that, and we could pretend we were there. We heard so much about it, so we'll use our imaginations. Last one.
Did you live on board and have all your meals on board?
Yeah.
Yes.
Okay.
We had our own rooms and we had a little suite and shared a bathroom. It was nice. They set it up for us.
Very nice.
Thank you so much.
Thank you.
Good morning. My name is Spencer Rankin, and today I'm really excited to be talking to you about my time aboard American Freedom this winter. A bit about me, I'm originally from Toronto, Canada. I grew up racing sailboats, and I loved STEM subjects, so that's why I came to Webb. Today I'm going to be talking about what American Freedom is, the daily tasks I had on board, what life was like, and I'll give you some highlights, including breaking in the rescue boat, opening the crankcase, and visiting San Francisco, and I'll finish off with what I learned. American Freedom is a 600-foot product tanker, meaning that she can carry anything from crude oil to jet fuel. She is a Hyundai design, built in 2016 at Philly Shipyard. She is operated by Crowley, and she's owned by American Petroleum Tankers, which is a subsidiary of Kinder Morgan. She has a 20-person crew. Most of them are doing 90-day or 75-day shifts. I was on for 47 days. And although 600 feet is small in the grand scheme of things, we were burning about 25 metric tons of fuel a day, so it's still pretty big. Well, I was on American Freedom. We were picking up refined petroleum at Cherry Point. It's a British petroleum refinery just a few miles south of the Canadian border. And we'd sail down to San Fran and unload at the ports of Richmond and Martinez. The sails were normally about 3 days, and we typically have about a 10-day round trip. And going back up, we'd be in a ballasted condition. I did 4 trips while I was on board. Some of my daily tasks, I was an engine cadet, so they revolved around following the third engineer. We would clean strainers. This here is the oil filter for one of our gen sets, so we clean that out with the ultrasonic cleaner. We would do oil changes on our Cummins engines, which powered our hydraulic power pack, and we also did an oil change on the lifeboat. They say to never do a bad job good, but apparently I was really good at making labels. So I used the label maker a lot of days. Some more repetitive tasks like pumping sludge, and every time you go in and out of port, you're maneuvering. So you need at least 2 people in the engine room, and you're gonna do a steering gear test before you enter the region. We also did, this is the saltwater scrubber pump. The motor on that short-circuited and blew out, and also its bearing was worn. So we had a spare motor that we put in, and we swapped the bearing, and it's sort of cool. You can see a little bit of cavitation effects on the impeller there. And of course, I was doing my C-term project while I was aboard too. So that involved around drawing a lot of the ship schematics. And this is the second deck. It's the deck you walk down to when you enter the engine room. So I would walk through these stairs every single morning and into the engine control room here. And we'd figure out what our daily tasks for the day were. The engine room is unmanned, so we had a regular lifestyle. So I would wake up at 7 and have breakfast at 7:30, and then we'd work from 8 to 5. The crew were unionized, so we had lots of coffee breaks, but not a lot of coffee. A lot more Monster than coffee. I already mentioned 3-day sails, and while I was on board, we didn't encounter much weather while at sea. At the dock, we encountered 45-knot winds, and we almost left. But at sea, this was about the worst weather we saw. But because we were in a ballasted condition coming back up to Cherry Point every time, we did have a fair amount of rolling. I checked our GM once, and it was like 9 feet, which is quite a lot. The food was edible. And I can't say much more than that. So, no, we didn't have a man overboard. When I arrived at American Freedom, they had swapped the outboard on the rescue boat because the old manufacturer had gone bust, and they needed to know they could repair it because you have to have an operating rescue boat to sail. So we swapped the outboard, and then they needed to break it in and put some hours on the engine, and I was voluntold to be ballast in the rescue boat. A lot of you will know that davits are notoriously unreliable on rescue boats these days because there's a lot of different systems and you can't see inside of them. And you're also hanging on a quick release. So I didn't really enjoy sitting there for 20 minutes while we tried to come back up to American Freedom. But it was a really cool experience and I got a pretty great photo out of it. About halfway through my time, an MAN superintendent came to do some tuning on the engine, and we got to open up the crankcase, which was an awesome experience. We were checking the alignment between the computer system and when it says that the engine is at top dead center, and where that engine actually is, and they were identical. And I think this experience exemplifies what C-term is about. It's about learning through experiences beyond textbooks. We're going to be designing ships soon, and it's hard to do that if you've never seen the inside of an engine. After we did that test, the superintendent put his MAN USB stick into the computer, did some calibration, and he played Sudoku for the next 3 days we were at sea. We had a SIRE audit while I was on board. SIRE is a ship inspection report program, and it's used by ship owners and operators and charterers to understand the quality of their fleet and its safety. Audits means questions being asked, so our chief engineer said, "I don't want to see your face, Spencer. Go into San Francisco." So this was really nice because you'll know that nowadays commercial ships have very short port calls and it's really rare that you get to get off. So I went in with another cadet and I love food and I'm a total foodie, so we got to go into Blue Bottle Cafe. We got to walk on Lombard Street, which is a super curvy, famous, picturesque street in San Fran. And we got to go to a nice bakery and get bread and had tacos in Richmond. So what did I learn? Ships are cool. I learned most of what I now know about how ships work from this experience. And I learned a lot about considering the people that are going to be using your product when you're designing it. So for instance, in our engine room, the lifting space provided to lift things from the lower deck to the second deck, 2 decks up, was about this big. So if you wanted to lift a pump and you were rolling at sea, you couldn't. There's no way. And getting to have these experiences teaches you to think about who's going to be using this product and making sure it's maintainable. And also, even though you're on a 600-foot vessel, you learn that you can get along with anyone if you really need to. So with that, I'd like to say thank you to Webb and Crowley and the crew of American Freedom for this experience, and I'd be happy to answer your questions. Yes, sir.
So she was American flag, I assume, so it was all American crew?
Yeah, it was a Jones Act vessel. Yes. Yes, sir.
If you could do one thing different on the design, what would it have been?
So the crew's opinion on this was they wanted more accommodation space. Because it's just an oil tanker, you don't need many decks up to get your navigational clearance. I think the lifting gap was definitely the biggest issue with the engine room because you couldn't service things on the lower deck. And also, they didn't have an escape hatch from the engine control room in the engine room, which different ships do. Ours did not, so you'd have to walk through the stairs. And it meets Coast Guard requirement, but our crews, they felt unsafe with that. Yes, sir.
I was the supervision engineer for the construction of those 4 ships.
Oh, wow.
That fellowship, and my question is, what's broken since we built this?
There is a lube oil tank for hydraulic lube oil that they added since you built the ship. And no one really thought about vibrations when they added that in. So it's 3 cubes, which is going to be about a 3-ton load. And at first it was vibrating a lot, so that was a big issue. But in general, everyone had a very high opinion of the ship. Not a lot had broken. They added a mezzanine in the steering gear room since its build, so that they had a lot more storage space for spare valves. And they wish that had been done at the shipyard, obviously, but that was an addition they made since it was built.
Well, we did find a few problems with the design, but the builders were unwilling to change anything. For instance, you look at your picture here, you'll notice that the bow bulwark does not go to the aft end of the forecastle. There's only handrails above the American part of the name.
Mm-hmm.
That is not as safe as having a full bulwark. I have visions of somebody being up there in heavy seas and getting strained through the handrails. Oops. So when we built a similar set of ships in China, I insisted, no, I want a full bulwark, and they gave it to me.
Yes, sir.
How was the traverse to Cherry Point? Were you doing that under pilot? And then related on the other end, what was it like your first experience going under the Golden Gate Bridge?
Yeah, so Cherry Point, I think it's about 8 to 12 hours of maneuvering out with pilot. Luckily, they knew I was from Webb. I wasn't going to be sailing the rest of my life, so I didn't stay up at night during maneuvering. I didn't have to be in the engine room. But you're going at slow speeds typically, and it's fairly long, and same on the way in. We would be sailing, by regulation, 50 miles offshore in case there was an oil spill. And San Francisco Bridge, really awesome first time experience, and I'd never been in San Francisco before, so it was super cool to see.
Cool.
Thank you for your attention.
All right, good morning, everyone. Recently, as I've been going through job interviews and seeing my initial class get ready to graduate, I've had a question on my mind, and that is, how does one become a professional? As you can already probably tell, this is going to be more of a thought exercise and less of a winter work presentation, but Emily let me get away with it. So when I go home to Maryland between semesters, I often go back to youth organizations I've been a part of, such as Boy Scout troops and Sea Cadet units. And I talk with them about what it means to go into a career and work towards becoming a professional. Now, when I was in middle school and high school, a lot of my peers, when they talked about becoming a professional, they often talked about becoming a professional athlete. And many of them were on school teams, varsity teams, club teams, travel teams, AAU, and had personal trainers, sports nutritionists, and sports psychologists. And they all started really, really young. And that's very true in pro sports. Tiger Woods is one of the most famous golfers on the PGA Tour. He started golf at 2 years old. Other sports follow suit. LeBron James started basketball at 9 years old. Can we take the same focus and timeline that so many children in America put towards professional sports, which have such a low percentage success rate, and apply it to engineering, which is, in general, a more fruitful career. I think I've come up with a 4-step plan of how we can have a paradigm shift in the country to implement this. Inspire children young, develop talent, integrate them in a community, and develop them as a professional. The key part to doing this is a word that Professor Onus has used consistently, and that is continuity. There needs to be continuity throughout the youth development experience. So, what was I doing before Webb? Well, in 2014, I was in 6th grade, I was 11 years old, and I found out about Webb Institute and the Naval Sea Cadet Corps. For those who might not be familiar, the Sea Cadet Corps is the Navy's youth development program. Now, learning about naval architecture and marine engineering at Webb gave me a direction to look towards. And then the Sea Cadet Corps showed me how naval architecture and marine engineering is applied in the United States Navy. So starting in 6th grade, I set sort of my direction of this is what I want to head towards, naval architecture and marine engineering, and becoming a naval officer. So from 2017 to 2021, I went to boarding school at Groton School in northern Massachusetts. Here, I was able to tailor my career and focus on STEM courses that would best prepare me to become an engineering student, or as Dean Werner would rather have me say, a student engineer. So in August of 2021, I arrived to Webb Institute for the very first time, because COVID had prevented PF visits, for orientation week with the class of 2025. And one of the key memories I have from then is Dean Werner's index card exercise. In fact, I have that index card from orientation week with me right here. Dean Werner asked us 2 questions. The first question, why are you at Webb? Here's my response. Graduate with superior knowledge and be a part of the NUPOC program. For those not familiar with the NUPOC, NUPOC is the Navy's Nuclear Propulsion Officer Candidate Program. The Navy takes civilian students, mostly from engineering colleges, and puts them on track to be either an officer in the nuclear fleet, or a nuclear power instructor, or a naval reactors engineer working at the Washington Navy Yard. Dean Werner then asked us a second question. What is one thing you're going to do to reach your objective? I said, work before play, no games on my academic or business devices. To this day, I have not had any games on my cell phone, my iPad, or my laptop, all 3 of which are at my desk throughout the day. So, with my objective set and my constraints defined, I embarked to freshman year. Wanting to be a nuclear officer, General Dynamics Electric Boat was a perfect fit. Here I got exposure to working on nuclear submarines and learning what the space constraints would be. When I returned from Electric Boat, I burned a full week of skips to go to Washington, D.C. and attend the Sea Air Space Symposium. Burning a week of skips is a trend that I have continued. It will come back. While I was in D.C., I joined the Naval Submarine League to learn more about the submarine community and hit the integrate in the community stage of my 4-step plan. Also in DC, I started formulating plans to go on a military sea term. I wanted a chance to experience what being a naval officer actually was. After many months of planning and coordination, I eventually got the Navy and the Coast Guard to agree to sponsor me for a gap year. President Michelle kindly let me take a year off of Webb and drop down to the class of 2026 so that I could do my sea term on Coast Guard cutters. My first cutter was Coast Guard cutter James Rankin, pictured on the left. It is a 175-foot Keeper-class coastal buoy tender. Here, I completed the required trainings and qualifications that I needed to go to the big ship, pictured on the right, Coast Guard cutter Polar Star, the nation's only operational heavy icebreaker. I owe many thanks to Lieutenant Brian Mills, Webb class of 2016, for helping put this gap year together. If it were not for him, this would not have happened. While I was on Polar Star, I worked as an ice navigation consultant with the operations department when we were down icebreaking in Antarctica. And then when we were in open water, I worked as an engineering cadet with the main propulsion division, working on my sea term projects. While I was in Antarctica, I happened to redo how the Coast Guard does icebreaker navigation and receives ice data. So when I returned to the United States, the U.S. National Ice Center, a Navy meteorology command, had me develop the standard operating procedures for icebreaker navigation and present them at the North American Ice Service meeting in Washington, D.C. I was able to then continue the Coast Guard and Navy involvements when I came back into my sophomore year for my sophomore winter work. Having already been to sea, I took my first office term at the U.S. Coast Guard Yard in Baltimore, Maryland as a junior naval architect. Keeping continuity with the polar operations theme, I worked on structural modifications for the Coast Guard's special purpose craft Ice Rescue Transport and the medium icebreaker Healy. Building off that momentum even further, I went to the Coast Guard's component of the North American Ice Service, the International Ice Patrol, to work as an ice navigation consultant after sophomore year. Here, I redeveloped the Coast Guard's tailored support products for the North Atlantic and actually fleeted out these products to the Navy, Coast Guard, and Allied forces during Operation Nanook in August 2024. Pictured above is me giving a poster presentation of my new product at the International Ice Charting Working Group at Naval Postgraduate School in Monterey. However, I'd gotten pretty focused on the Coast Guard, but that's not what the index card says, as we see up here. It very clearly says NUPOC program. So I reoriented myself, and went to the Navy for my junior year. I worked at Portsmouth Naval Shipyard as a nuclear engineering technician. This was a wonderful experience because it gave me a broad view of the nuclear Navy. I was able to get the operational perspective from the boat crews that were in the yard with their boats. I was able to get the engineering perspective from the engineering duty officers working at the shipyard. And I also got the regulatory perspective from the Naval Reactors Field Office that represented Admiral Houston, the director of Naval Reactors. While I was at Portsmouth, I submitted my formal application to the NUPOC program. I think this was the perfect time to do it because I had the proper perspective of what the nuclear Navy was and how it interfaced with the non-nuclear components. I'm fortunate to be able to say that on April 17th, I was accepted by Admiral Houston into the NUPOC program as a Naval Reactors engineer. Thank you. I will spend the first 5 years out of Webb working for Admiral Houston at the Washington Navy Yard in DC. But this did not happen overnight. This only happened because I was able to demonstrate continuity. I was inspired young. Webb allowed me to develop my talent. The Navy integrated me into their community. And now Naval Reactors is allowing me to develop as a professional. It's been great to see how I've been able to grow over the past years, and I'm very excited for everything that is to come. Thank you all for listening, and I'll now take any questions. No questions? That was easy. All right. Oh, question in the back.
First of all, congratulations. I mean, you're like the poster child for stick-to-itiveness, so well done.
Thank you.
I'm curious, you learned about Webb at a very young age. I'm curious, do you recall in what context you first learned about Webb?
Yes. So had an unfortunate change in family circumstances, and we basically lost all income in my family. We're just living on Social Security. And so I looked up free colleges as soon as that happened. And basically, if you come into my house, there's these giant poster boards, like 4 foot by like 3 foot posters that my mother had like charted out everything. She had like a plan for middle school, a plan for high school, a plan for college. And it's just basically every single opportunity that you could imagine. And the only reason I was able to go to boarding school is because there's this program through the Institute for Educational Advancement called the Caroline Bradley Scholarship, and they'll sponsor you to any private high school in the country. So that's the only reason I was able to afford boarding school. Otherwise, I would have been at public school and just been a subject of the normal education system.
Well, thank you so much. Well done.
Sure, thank you. Max.
Yeah, you spoke about your continuity with your sea terminal Star and about changing how ice navigation is done, so I'm curious if you could detail a little bit more about that.
Sure.
I'm curious about how to gather data and what your contributions were to that detail.
Sure, absolutely. So I'll actually go back to that slide so you can see the ACTA screen. So prior to Operation Deep Freeze 2023, which I was on, the U.S. National Ice Center had been providing ice data to Polar Star by way of layered PDFs. So that's just like a PDF that you can click layers on, and it's just a document that you can see. And you basically had navigators with a laptop with that layered PDF, and then their electronic chart display and information system, the ECDIS, which is pictured on that screen, and just trying to compare the two and just having to do it by estimation. For Operation Deep Freeze 2023, we got Starlink Military, courtesy of the Air Force. And I was able to download ice thickness data from NOAA satellites in near real time, like a couple hours latency, and then use geographic information systems to export those ice thickness data as shapefiles. And then I was able to import those shapefiles via secure drive into the ship's ECDIS system. So we actually had ice thickness data on the track lines that we were drawing over as opposed to having to estimate with our eyes. Yeah. Yes?
Did they make you do a polar plunge in Antarctica?
Yes. Yeah, so anyone who's been in the service may be familiar with the line crossing ceremonies. So we went from Seattle, Washington, all the way down to Antarctica. So I've done golden shellback at the equator and international dateline crossing, and then crossing the Antarctic Circle, we did the red nose ceremony. Wow. Yes?
I don't know if you've been notified yet, but I'm on the American Society of Naval Engineers Scholarship Committee. And 2 weeks ago, we selected you as one of our awardees this year for the scholarship.
Yes, sir.
As Webb continues to try to get the best and brightest to come to Webb Institute, would it be honest to say Webb was instrumental in making your dreams come true?
Absolutely. Absolutely.
We'll use that.
You know, one of the hardest things today, you know, for parents is to keep their kids away from these devices and off of video games, and they become time wasters. How did you know, keep your discipline up on that? You came here to Webb and said you're not going to spend your time wasted on games and everything. How did you make sure? How did you do that? I mean, it's really hard for kids to get away from these things.
So that starts pre-Webb as well. Developing that sort of mentality of being detached from devices started for me pre-Webb. When I was 5 years old, my parents had me start in study of music. So I studied violin, and then I picked up bassoon and voice and composition. And I studied at Peabody Preparatory of the Peabody Conservatory in Baltimore for over 7 years. And so whenever I wasn't doing homework, I was usually almost always practicing music and developing that skill. And so screens, devices, and video games were just never in my life. And even going to boarding school, I had class Monday through Saturday, and I had mandatory church service with choir rehearsal on Sunday. So video games were never a necessity. I never felt bored. I always had something to do, something to be productive with. And so coming to Webb, it was pretty much no factor. I picked up cycling shortly before starting at Webb, and so I've often enjoyed cycling with the Long Island Bike Club and just getting off campus and clearing my mind rather than staring at a screen.
Can you fill in the timeline for the next 5 or 10 years?
Yes, so my next 5 years will be at Naval Reactors Headquarters in Washington, D.C., working as a staff officer under Admiral William Houston. And then at the 5-year mark, I'll probably have a crossroads of I can either stay at Naval Reactors as a civilian and resign my commission, or I can lateral transfer to a different community within the Navy.
Thank you.
Sure. All right, thank you all.
Hello everyone, welcome to my senior year winter work experience presentation at NETSCO. Before I begin, I would first like to give a brief outline of today's presentation topics. I'll first just go over a brief introduction of myself, followed by an introduction of NETSCO. I'll then talk about my work on different cement offloading barges that I did while I was there, as well as the development of a new generation articulated tug and barge system. I'll then touch on a few of the smaller, more unique projects that I had the opportunity to work on. Followed by this, I'll just discuss my life on the Great Lakes and then the lessons I learned through this experience. So thank you. So a little bit about me. I'm originally from Wichita, Kansas. During my freshman year winter work, I worked for General Dynamics NASCO as a pipe fitter. While there, I mostly worked on the construction and testing of their ESBs and new TAO class. My sophomore year, I was also with the Military Sea Lift Command, and I was on the USNS Charles Drew. We started our voyage in Korea, and then we sailed to Japan. From Japan, we went to Guam, and from Guam, we went around Indonesia. We met up with the USS Nimitz and a few other naval ships and did a few underway replenishments, which was really interesting. And then my junior year, I worked for Kiel Maritime, which was a small commercial design firm located in the Northern Territory of Australia. While I was there, I mostly worked on small commercial vessels, fishing vessels, trawlers, and I also got to work on the design and testing of a few crocodile cages, which is a big industry there, catching crocodiles. Most Australian thing you can ever think of, right? And then last year, I worked for NETSCO, which is also a small commercial company. My thesis is a numerical investigation of Titanic's calm water maneuvering characteristics. If anyone is sticking around for this Monday, I'm giving a presentation on that, which is also my hobby. And after graduation, I plan to work for General Dynamics Electric Boat. So NETSCO is a naval architecture and marine engineering firm that provides technical guidance for a wide variety of different marine-related projects. One of the most interesting parts of the company is their work along the Great Lakes and Great River systems within the United States. The Great Lakes, Great Rivers market is a pivotal component to the American maritime industry, yet it is hardly discussed within traditional naval architecture curriculum. Many large and historical bulk carriers operate along these waterways, which inspired me to pursue an internship in this area. NETSCO also pursues several projects that are not traditional within the maritime market, and as discussed later, these markets provide interesting opportunities for problem solving. So one of the main projects undertaken during my experience at NETSCO was the design, construction, and commissioning of various cement offloading barges. Cement is a binding agent used in the development of concrete. It is comprised of clay and limestone dust it is comprised of clay and limestone dust and undergoes several different stages of transportation. Oftentimes, cement is processed in a location that is different from the local storage facilities. For this reason, it must be transported using rail, marine, or vehicle technology, and transporting cement along inland waterways offers the most efficient transportation method due to a vessel's ability to transport cargo in mass quantities. Several technologies have been developed to optimize the offloading of cement. One of these was the development of cement offloading barges. These vessels are permanently moored along the riverbank and use a large vacuum arm to remove product from hopper barges delivered by pushboat. Cement dust is then transported to a temporary holding kettle along the barge before it is delivered to an offshore or an onshore holding silo. So during my time at NETSCO, I had the privilege of participating in the commissioning of one of these systems. This experience shed light onto the required interconnectedness of various industries and also exposed me to the world of project management. I also performed several structural calculations of these barges while in the office, which exposed me to greater parts of the design process as well as finite element analysis methods. I also had the opportunity to participate in the design of different mooring support systems, which mooring supports are often difficult to design due to the extreme changes in river water levels. And one project could not be moored for more than, one project could not be moored using the standard line and mooring winch technology because there were two permanent dolphin support pylons that were right next to the barge. So because of this, the engineering firm and I concluded that it would best serve, the mooring system would be best used in terms of a rail and guide system. So I was part of the structural design and initial feasibility study of this. Much of my time was also dedicated to the initial concept design of a new generation articulated tug and barge system. ATBs are pivotal pieces of technology necessary for maintaining the American maritime industry. While at NETSCO, I had the opportunity to work on the design of a novel diesel-electric ATB, and throughout this process, I gained a greater understanding of tug and barge notch integration requirements. And through this work, I learned about the advantages and disadvantages of attaching hull blisters for greater connection between the tug and barge. Although new ATB designs provide bow shapes that enhance the efficiency of the vessel, they sometimes cannot always be connected to barges with older notch shapes, so it's important to optimize the design of the tugboat so that it maintains efficiency resistance-wise while also having the compatibility to work with vessels that might be older or less efficient. While also taking into account developability and initial cost, I had the opportunity to develop the lines plan and the hull form. I also got the chance to work on several smaller projects that were very unique to the maritime industry. The first of which was a barge refit requested by the Cleveland Metro Parks Zoo. This barge was constructed in the 1880s and still retained original rivets along the bottom and side shell. The barge was then converted into a floating restaurant. And while at NETSCO, I had the opportunity to participate in a client meeting where the Cleveland Metro Parks Zoo wanted to convert this floating restaurant into a lakeside, basically like a lakeside nature preserve, which was really interesting. And this allowed me to gain a greater understanding of the interplay between marine and land-based engineering, because there was a lot of overlap between the different regulations and requirements that we had to meet, and there was also consideration on the feasibility of just sinking the barge right there and turning it into a building. So that was kind of an interesting project to work on. The meeting also took place at the zoo, which was not on my bingo card for my 2025 work experience, but it was really cool nonetheless. Yeah, and I also had the chance to work on a new truckable tug design, which had a watertight bulkhead along the center line of the vessel and could actually be folded in half with a removable superstructure so that it could be shipped by truck to different port facilities. And that was also a really cool project to work on, because that was how the ship that I was on sophomore year obtained their water and fuel barges. They were shipped using these truckable tug designs. And if you've ever seen one operate, they're really fun to see. They kind of look like bumper cars. I think it'd be really fun to make one in like a garage or something and like race it around. But yeah, that was a really good experience. And life on the Great Lakes was also very interesting. I'd previously never been to this part of the country before, so it was fun getting to learn about the unique maritime history that was there. I learned a lot about this one shipwreck that happened on Lake Erie it was about the sinking of the Markin Bessemer No. 2 railcar ferry, which is also the largest shipwreck that occurred in Lake Erie, and they still have not found it 100 years later. So it's definitely one of those more mysterious, kind of ghostly Great Lakes stories that you hear of. I also had the opportunity to look at a lot of the different ships very similar to the Edmund Fitzgerald, and also got to see the Anderson, which was the ship that was operating with the Edmund Fitzgerald when she sank in the 70s. So that was a really cool thing to see. And also, I just love steam technology. So having a maritime industry that was still operating using steamships or reconverted steamships was a really cool experience for me. I also had the opportunity to explore the markets and go to the local aquarium. You'll see in the bottom right image is a picture of my fish. Her name is Pearl. She's here in the classroom if you want to see her. But I actually traveled with her from New York all the way to Cleveland, and that was a kind of fun experience. And on my way back, actually, the Airbnb I was staying at, the reservation ended one day before my last day of work. So I actually brought her with me in my car, and then I asked my supervisor, I was like, this is probably the weirdest request you've ever heard an intern ask you, but like, can I just keep my fish at the desk? And he was like, well, we do have a board meeting, but sure. So that was good. And also while I was there, Lake Erie froze completely over, and I'd never seen such a large body of water freeze like that before, so that was also a really cool experience. And there were several lessons learned throughout this experience. Developing a good relationship with clients and colleagues significantly contributes to one's ability to work effectively and efficiently. Just kind of adding on to what I've learned here at Webb, relationships always come first, and it's important to put that before other components in your job. Of course, I mean, the design-wise is also extremely important. And oftentimes projects will be in a state of great flexibility, so it's important to have a growth mindset as you're continuing to go through various different iterations in the design process. That was also a really important part for me. Also, voicing your ideas, especially as an intern, I think is something that I had to learn while I was there, because but previously, before this experience, I kind of didn't necessarily want to elaborate on different ideas I had because I thought, well, I'm an intern, I don't really know anything yet, like who knows. But while I was there, the previous mooring system design I talked about that used tracks to go up and down the riverbank was actually a design I proposed, and the design they actually continued to work on and construct was my initial proposal, which was a really cool experience. Also, just considering different methods of integrating several different industries, I learned a lot about the cement industry while I was there. And growing up in Kansas, I see grain and cement silos like all the time. So it was really interesting to learn about how the maritime industry kind of plays a really important role in that, and just how different systems have to be integrated in both. Also, sophomore and junior year, we learn everything about pipe fitting and how to best transport fluid through pipes. And so it was really interesting to see how that is applied to something like cement, where it's kind of granulized and still is transported like a fluid, although it isn't necessarily one. And that was a really cool experience. Also, lastly, I'd never driven in the snow before. And now I was in like lake effect snow, land, so that was crazy. And actually the first day I was there, I was late to work because of course I was, the snow was insane and I didn't know how long it would take to get there, but luckily everyone was really nice about it. So yeah, that was my experience. Thank you so much for listening to me. Yes.
I have one question. You served on ships that carried cement, yes?
So the question was if I served on ships that carried cement.
Or you worked on designs for ships that carried cement.
Yes.
I'm wondering, is there any communication between that industry and the offshore industry, particularly in the Gulf of Mexico, where there are a great number of offshore service vessels, as they call them, that carry cement out to the drill rigs, and particularly the ones that are making the wells. There's a lot of cement used in oil well drilling, and they handle the cement with a lot of air, transport of air. Is there much communication between those two industries?
Yeah, I would say there's definitely a lot of communication between those industries. Just to touch on your comment regarding the use of air to transport cement, one of the designs that I had the opportunity to work on incorporated the use of a small air layer near the inner bottom of the vessel, so that whenever it was time to offload cement from the barge into the silo, you kind of could actuate that process by implementing this pneumatic air technology that we see so heavily in the cement industry. So yeah, that was a cool experience. And also in terms of the cement industry in the Gulf of Mexico, although I didn't necessarily work as much with cement being transported in that location, I did get the opportunity to work on a few spacer barges and offloading barges that are located in Norfolk. But the primary amount of work I had, or the most amount of work I had, was for shipping within the Great Lakes systems and the inner waterways. Yeah. Yes?
What does the growth mindset mean to you?
Sorry?
What does the growth mindset mean to you in the internship context again?
Oh, I would say the growth mindset in terms of the internship context would probably be the same as my growth mindset here. I think that it's learning through failure and having the mindset of solving a problem, recognizing that a failure isn't necessarily the end of something, rather it's just the additional step in achieving a goal that you have long term. Yeah, I would say that in a lot of ways a design spiral cannot occur without a growth mindset, or else it would just be a circle. And so in terms of yes.
I just like to comment for a second. You mentioned speaking up as an intern, and well, everything has its limits, of course. I think that's a great comment, and I remember one of the great things I learned from one of our principal engineers, Andy Davidson, was if you have an impossible problem, give it to the intern, because they don't know it's impossible. But anyway, I commend you for bringing that up, and I encourage all the other Webbies here to go through your internships to not just quietly sit and learn.
Well, thank you.
For coming to listen to them. I just want to reiterate again that I'm here every day and I see them walk through the halls like zombies. I mean, they're up till all hours of the night and they're getting up early and they're taking tests and they're presenting. I mean, Hendrix he said he has his thesis presentation on Monday. Y'all probably remember how that went. So I just want you guys to stand one more time and I want to give all of you guys a round of applause.